Okay, this is the IGCSE Physics October-November 2024. Yeah, paper 4 about theory. We see the question number 1 about spring. Okay, number 2 it's about force, maybe force and power. Yeah. Number 3 it's about moment of force. Number 4 is about heat specific heat capacity, or it's about heat energy. And number 5 is about wave. Yeah. So it's about wave. And then number 6, what? Wait. Oh, number 6 is about resistor. Done. Let's check. Oh, number 7, it's about magnet. Yeah, electromagnetic. Okay. Let me try question 1. Question 1 is about spring. A spring is suspended from the clamp, figure 1.1. So the pointer attached to the lower end of the spring. Okay, this is meter roller, pointer, spring, and this is loads, some loads. Students suspend load different weight from the spring and record the reading on the meter rule. The reading with graph that the student obtains. Okay, this on the x-axis is weight in Newton, and on the y-axis is reading of the pointer, yeah, in centimeter. Using figure 1.2, determine reading the meter rule when no weight is attached to the spring. No weight mean weight is 0. Yeah, it's about in this position. Between 40 to 50. This is 1 square is 2. Yeah, 42, 44, 46, 48, and 50. So it's between 42 to 44. Yeah, 43. Yeah, it's about 43. Is 43 in centimeter. And then weight 5.6 is attached to the 5.6. 5.6. Yeah, this is 5. This is 6. So 5.6. 5.1, 5.2, 5.3, 5.4, 5.5, 5.6. Here, yeah. We check here is this position, yeah. Sorry, this position. This position is about 63. Yeah, 63. Here, 63. I repeat, yeah. When weight is 56, the attach of the spring is 56 in here, 56 in here, here 56, and then we up, we get this one, and then we move here. This is about 6. 1 square is 2, so this is the middle between 1 2 and 1 4, so sorry, 62 64, so this is 63. Yeah. Here is 63 in centimeter. Calculate the extension of the string when the weight achieves 56. The extension, yeah, so the extension delta x here. Mean x2 is 63 minus 43, so equals to 20 in centimeter, or this is 0.2 meter, 0.2 meter. Then what else? Using the volume values from A, calculate the spring constant of the spring. From Hooke's law, yeah, remember Hooke's law is F equals to K times delta X. So constant springs means force divided delta X. Yeah. Force is weight. We have weight is this 56, 56, and the extension is 0.2. So this equals to 6, 2, 3, 28, 280 in Newton per meter, in Newton per meter. And then what about this one? An object mass 0.50 kilogram attached to spring. Calculate the weight on the object. Remember the weight is W is mass times gravitational acceleration. 0.50 times, we use 10 as a gravitational acceleration, so this is something with 5.0 Newton, yeah. 5.0 Newton. And then the object is pulled downward until the tension spring is 6.5 Newton. The object release. Calculate the acceleration of the object immediately after release. Okay. They have tension, so when spring tension is 6.5. Oh, sorry. The object pulled downward until the tension is spring 6.5 Newton. The object release. Calculate the acceleration of the object. Acceleration Acceleration means force divide mass. Yeah, we have two force tension group. Yeah, 6.5. Also we have weight 5.0, and then the mass is 0.5. So this equals to 11.5 divided 0.5 means 23. This 23 meter per second square. Then do we still have question for? Oh, this is different question. Yeah.